For MAT 183 Calculus 1 Assessment 3 video presentation, we from Group F present to you the application of differentiation rate of change. This whole video is prepared by Group F from class AS1202B in program AS120 of Universiti Teknologi Samarahan Campus 2. This video will be evaluated by Madam Liew Chin Ying. Group F consists of 3 members, which is Kimberly, Clara, Anak, Aldrin, Norfatihah, Najwa, Binti, Mohamad, Zainal, Fatin, Ayunie, Binti, Mohamad, Azman. Now let the presentation begin.
So, for the introductions, first, I'm going to explain about applications of derivative. So, what is derivative? In mathematics, the derivative of a function of real variable measure the sensitivity to change of the function value, which is output value, with respect to a change in its argument, which is input value. Derivatives are fundamental tool of calculus. Next is the applications of differentiation in real world. The process of finding derivative is called differentiations. Next is the applications of differentiation in real world. The example is to calculate the profit and loss in business using graph. Moreover, it can be used to check the temperature variations. Next, to determine the speed or distance covered, such as mile per hour and kilometer per hour. Next is applications of related rates. In the differential calculus, related rates problem involve finding a rate at which a quantity changes by relating the quantity to other quantities whose rate of change are known. The rate of change is usually with respect to time. Moreover, the example is like snowball melting, a ladder falling, and a balloon being blown up.
Now let's solve a problem.
Oh, today is Saturday and it's weekend, so I want to jog around my neighborhood for a while. So I decided to bring my favorite water bottle, which has radius of 3 cm and height of 20 cm. I have filled this water bottle full of water, and I suddenly wonder how much volume of water is filled inside this bottle if the height of water increase at rate of 1.5 cm per second. I am not sure about the technique that we use to calculate it.
Let's help Fatihah to find out what is the rate of volume of water filled in a bottle.
Okay, for the problem solution, we must refer to the problem statement and highlight the important key point from the statement. So first is cylinder bottle, radius of 3 cm, height of 20 cm. And other is volume of water per second, the rate of 1.5 cm per second. For the first step is we write the information given in the statement, which is the radius is equal to 3 cm, the height is equal to 20 cm, and the rate of the height per second is 1.5 cm per second. So we write it like this. We define the height as dh over dt because we derive it to the time. So it equal to 1.5 cm per second. Next, I already sketched the bottle in cylinder shape. So we label it with the radius as r equal to 3 cm and the height as h equal to 20 cm. For the second step, we must write as what we want to find. So from the statement, we know we want to find the dV over dt, which is the volume we will derive to the time. So dV is the volume, dt is the time. When this line is mean when r, which is radius, is equal to 3 cm and h is the height, is equal to 20 cm. And this one. For the third step, we must write the equation of volume of the bottle, which is in a cylinder shape. So, the formula for volume of cylinder is volume is V equal to pi time r square, which is radius, and time with the height, which is at h. So we just substitute the radius, which is 3 cm, into this formula like this. Make sure put in that bracket 3 square and height. So we evaluate it and we get 9 pi time h. From this equation, we know that the radius, which is r, is fixed. This is because it will not change. So for step number 4, we derive the equations this with respect to time. We take the equation that we do just now, which is V equal to 9 pi h. Then we derive it with respect to time, which is dv over dt. Dt means time, equal to 9 pi. And we derive this also, so it will be dh over dt, like this. It will be like this, and this. So for step number 5, we solve it by substitute the value of dh over dt into this equation. So it will be like this. dv over dt equal 9 pi, put in the bracket, this to this, 1.5. And we evaluate it and we get 42.41 centimeter cube over second. Or we can write it like this in pi term, which is 27 over 2 pi, don't forget the unit, centimeter cube over second. And for the last step is the conclusions. Don't forget about the conclusions, okay? So we must put the volume, which is V, volume, like this, increases at the rate of, we can write either one, so I choose this, 42.41 centimeter cube per second. That's all.
So 42.41 centimeter cube of water will be filled every 1 second in the bottle. Now Fatihah know, Fatihah is happy.
As for the conclusion, to summarize, we know that from the problem statement, we have identified the rate of volume of water filled in the bottle using the application of differentiation, which is rate of change. Rate of change not only can be used for volume, but it can also use to calculate area, distance, and etc. For instance, if there is a problem on how to calculate the change in distance of a car, we can use rate of change of a distance to find the solution. In short, application of differentiation for rate of change can be used in various cases in our daily lives.
Now this is the list of references that have been used in preparing this presentation. These references consist of 4 websites. Lastly, this video is created using Microsoft PowerPoint, UCut Video Editor, VN Video Editor, and the only music added is Sunny Morning. That's all for our presentation today. We like to say thank you.